We've journeyed to planets of pure iron, worlds so dense and heavy they crush the very laws of physics. But the universe is a place of balance, of opposites. For every unyielding iron world, there is its ghost, a planet so impossibly light it defies all logic. Imagine a world the size of Jupiter, our solar system's grandest giant, yet with the mass of tiny Earth. These are the celestial phantoms, the gas dwarfs. Or, as astronomers have nicknamed them, the superpuffs. Some are so ethereal, they have the same density as cotton candy. This story begins in 2012, when the Kepler Space Telescope, our tireless planet hunter, detected something truly bizarre. It was a star system named Kepler 51, located about 2,600 light-years away in the constellation Cygnus. Orbiting this star were 3 planets, Kepler 51b, C, and D. At first glance, they seemed like typical gas giants, each one roughly the size of our own Saturn, massive worlds dominating their cosmic neighborhood. But when astronomers managed to measure their mass, the results were staggering. They were shocked. These planets were unbelievably, almost comically, light. Let's focus on Kepler 51d. This planet is a giant, with a diameter nearly as large as Saturn's, but its mass, it's less than 5 times the mass of Earth. To put that into perspective, Saturn, our familiar ringed beauty, is 95 times more massive than our home world. This incredible discrepancy means that Kepler 51d is mostly empty space. Its average density is less than 0.1 grams per cubic centimeter. That's the same density as styrofoam, the same density as a fluffy cloud of spun sugar. If you could find a cosmic bathtub large enough to hold it, Kepler 51d would float effortlessly. These are, without a doubt, the fluffiest, most gossamer planets ever discovered. But how is this even possible? How can a planet grow to be so enormous, yet weigh so little? The secret lies in its atmosphere. Gas dwarfs are believed to have a small, rocky core at their center, much like Earth. But this core is shrouded in a colossal, incredibly thick envelope of hydrogen and helium gas. Now, you might be thinking, isn't that just like Jupiter or Saturn? Not quite. The key difference is gravity. Jupiter and Saturn are so massive that their immense gravity crushes their own atmospheres, compressing the gas into a dense, almost liquid state deep inside. Gas dwarfs, however, have very weak gravity for their size. This feeble pull can't reign in its own atmosphere, so the gas isn't compressed. Instead, it puffs out, expanding for thousands upon thousands of kilometers into the void of space. It creates a gigantic, fluffy, almost transparent cloud around a tiny, hidden core. Imagine taking a journey into one of these superpuffs. As you descend, you wouldn't find a surface, no solid ground to land on, just clouds, an endless ocean of gas stretching for thousands of kilometers. The atmosphere would be thick, a dense fog, but paradoxically light and thin. You would just keep falling, for days, maybe even weeks, drifting through layer after layer of hydrogen, methane, and swirling dust. Perhaps you'd even encounter clouds of water vapor, like ghostly terrestrial clouds stretched across a planetary canvas. And then, finally, deep within the heart of this immense haze, you might hit the core. A small, rocky ball, no bigger than our own Earth, hiding inside a cloud the size of Saturn. A planetary pearl concealed within an ethereal shell. But these fluffy worlds are as fragile as they are strange. Their existence is a delicate balancing act. Because their gravity is so weak, they're in a constant battle to hold on to their vast atmospheres. If a gas dwarf orbits too close to its parent star, the intense heat and stellar wind will begin to boil its atmosphere away. The star's radiation acts like a relentless blowtorch, stripping the gas, layer by layer, until the planet is peeled down to its bare, rocky core. It's a process called photoevaporation, and it leads to a fascinating theory. Many of the super-Earths and mini-Neptunes we see scattered across the galaxy rocky worlds, slightly larger than ours, might actually be the corpses of former gas dwarfs. They are the planets that lost their puff, their majestic atmospheric shrouds blasted away by their own suns, leaving behind only their skeletons. The Kepler 51 system provides a crucial clue. It's a young system, only about 500 million years old. In cosmic terms, that's just an infant. Our own solar system, for comparison, is 4.5 billion years old. This suggests that the superpuff stage might be a temporary phase in a planet's life, a fleeting moment of youthful grandeur. A planet is born with this huge, low-density atmosphere, but over billions of years, gravity and stellar radiation conspire to strip it bare, transforming it into a much smaller, denser world. So, we may be looking at a snapshot of planetary adolescence, a cosmic awkward phase before these giants either grow up or get torn apart. But for now, they're out there, ghost worlds, drifting silently in the dark. Planets that appear solid and substantial from a distance, but are mostly illusion. Worlds made of little more than fog and mystery. Imagine flying a spaceship towards one. From far away, it looks like any other gas giant, a colossal sphere swirling with color. But as you get closer, things would get strange. You wouldn't crash into a solid surface. You would just pass through. Your ship would be enveloped by a pink and blue haze, the colors of its strange atmosphere. It would be like flying through a dream, or perhaps a nightmare. Because even in the fluffiest of clouds, the pressures and temperatures would eventually become extreme. In the vastness of space, even something as gentle as a cotton candy world can hide a deadly core. Thank you for joining us on this journey to the ghosts of the galaxy. Until next time, keep watching the dark,